Hello and welcome to another ramble with me, a lover of mathematics and also pretty obsessed with past exam papers. So, paper that we are looking at today is the department's November 2022 paper 1. And the question we're focusing on in this video is 4.2. The graphs of f of x is equal to x squared minus 4x minus 5, so that's a parabola, and g of x is equal to a times 2 to the x plus q, so that's an exponential function, are sketched below. Okay, so I'm just going to highlight that for myself. So we have the parabola, and we have the exponential. Okay, cool. So E and H, E and H are the x-intercepts of f. C is the y-intercept of f and lies on the asymptote of G. Okay, the two graphs intersect at D, the turning point of f. Okay, lots of info. Let's get into it. Write down the y-coordinate of C. So C is the y-intercept of f. And y-intercept occurs when x is equal to 0. So let's work that out real quick. So f of 0 is equal to 0 squared minus 4 times 0 minus 5. So that is equal to negative 5. And so the coordinates of C are going to be 0, negative 5. Just going to fill that in on my diagram. Okay, right. And that also then tells us the asymptote of G, right? That will be y is equal to negative 5. Okay, right. Next question. Determine the coordinates of D. Okay, so we know what Q is now for the exponential dude, because our most basic exponential function, y is equal to b to the x, its asymptote is the x-axis. So the fact that the asymptote is now at y is equal to minus 5 tells us that our basic exponential has been moved down 5 units. So q is negative 5. But we don't know what a is yet, we haven't been given a point that lies on G that would help us figure out what that is. Where I'm getting at is, in as much as D is a point of intersection between these two, we don't have enough information to do like a simultaneous equation situation, or to say this is equal to this and let's figure out which x value makes it true, right? So then we use the other piece of information we've been given about D. We've been told that D is the turning point of f. So I'm going to try and find the turning point of f using this equation. And I'm just going to use that formula that says that the x-coordinate of the turning point of a parabola is negative, let's just write it here, negative b over 2a, right? Given that your function looks like this. So in this case, our a is 1, our b is negative 4, and our c, just for fun, is negative 5, right? So I will sub that in. So b is negative 4, and then a is 1. So that ends up being positive 4 over 2, which is 2, right? And if you don't know this formula, so if you didn't know this formula, how else could you do it? Well, you could, there's a couple of options really. So I want to rotate this, make it look cool. So the first alternative would be to find E and H, the x-intercepts, right? Make this equal to 0, solve for x, and then average them. So find which x value is right in the middle of E and H, and that will give you the x coordinate of D, because we're using the fact that the parabola is symmetric about the axis of symmetry passes through the turning point. So if you can find which x value lies right between E and H, then you have found the x coordinate of D. So that's another quick way to find to begin finding the turning point. Another alternative would be to complete the square, right? So get this into a form like this, because the P and the Q will then tell you what the turning point is. But yeah, anyway, forward we go. To find the y coordinate of D, we want to find, well, what is the value of the function when x is equal to 2? So that will be 2 squared minus 4 times 2 minus 5. So that's 4 minus 8 minus 5, which is negative 9. Right, so the coordinates of D are 2 and negative 9. Oh, of course, then another way that you could find the turning point is using calculus. So you could find the first derivative of f, make that equal to 0, because we know that the turning point occurs when the gradient is equal to 0, and that would give you the x coordinate. So 4 different ways that you could find the coordinates of the turning point of a parabola. Anyway, right, so we have 2 and negative 9 as our coordinates for D. Yeah, I don't know how visible that is, but anyway. Okay, righties. Let me just double check my answers so far with the memo. Y is equal to minus 5. Oh, they just asked for the y coordinate. Oops. So this is for the first question. They just asked for the y coordinate. I gave them the x and the y. But yes, the y is minus 5. And then for the turning point, we get 2 and negative 9. Awesome. Okay, so now for the next question. And I am running out of space, but I am going to force matters. Right. So we are asked to determine the values of A and Q. Okay, so I've already explained what Q is, right? Q is negative 5 because our exponential graph has moved down by 5 units. The asymptote has gone from x-axis to here. So Q is minus 5. To find A, we can now use the point, right? Because we were told that D lies on F and on G. So we can use this point to figure out what A is, right? So we're going to say sub in the point D, right? So the y value is, negative 9. Then we have A times 2, right? 2, yes, to the power of 2 plus Q, which is minus 5. Right, add 5 on both sides, and we have A times 4. Divide by 4 on both sides, and we have negative 1 is equal to A. Right, which we expect, right? The moment our exponential is underneath the asymptote as opposed to on top, we know that our A is a negative number. So we have these two as our answers. Q is equal to negative 5 and A is equal to negative 1. Just checking real quick. Yes, A is equal to negative 1 and Q is equal to negative 5. Perfect. And then the next question says, write down the range of G, our exponential. So the y values go all the way down to negative infinity, but they do not go beyond negative 5. Can't be equal to negative 5, can't be greater than negative 5. So that's the range of g. So g of x is strictly smaller than negative 5. Or if you're into the interval notation, you would say that g of x is an element of this interval, anything from negative infinity up to but not including negative 5. Okay, happy. Right, the grand finale of the question. So let's just write down what we know so far. So this is 2 and negative 9. This is y is equal to negative 5. Okay, so the next question asks, determine the values of k for which the value of f of x minus k will always be positive. Right, so we want to figure out for which values of k, and this minus k, right, because we are adding or subtracting a number to the function, if that makes sense. So that means that we are translating it vertically, right? We're moving it up or down. If we're adding it to the x, right, to the input directly, then we'd be moving it left or right. I hope that makes sense. Anyway, so we want to figure out, well, by how much do I need to move this parabola in order for all its y values to always be positive. No matter what the x value is, the graph, the function will always output a positive y value. Right now we can see that we're only getting positive y values for these x values and for these x values, right, for this piece of the graph. So the key here is the turning point, right? The moment the turning point is above the x-axis, then this is where we're at our happy place, where all of the y values that this function outputs are always positive. So we want to get this turning point above the x-axis, which means the turning point needs to go from being at negative 9 to more than 0. So we need to move this parabola up by more than 9 units, right? So we would have to move, so this minus k that is being added to the f of x would have to be greater than 9, and it has to be strictly greater than 9, because if it's equal to 9, then the turning point will sit on the x-axis, and so that means the one of the y values for this function will be equal to 0, right? Which is not what we want. 0 is not positive. 0 is just 0. So in order for it to always have y values that are positive, i.e. y values greater than 0, that means this turning point will have to be moved up by more than 9 units. And so if we rewrite this inequality so that we just have k instead of minus k, that means we're dividing by a negative or timesing by negative 1. Either way, that is going to flip our inequality sign around. So for any value of k that is smaller than negative 9, f of x minus k will always be positive. So for instance, if you think about k is equal to negative 11, right, then we would have f of x minus 11, which is the same as f of x plus 11, right? So that would be this parabola moved up by 11 units. So the 9 units takes it to the x-axis and then bumps it up. The extra 2 units are going to put it somewhere over here. So you can see that with that graph, all of its y values are positive. So that is our answer for that one. Yes, we agree, Memo? We agree. Awesome and perfecto. Oh no, Kalki.